their income over the last year, how many weeks they worked last year, kind of the average number of hours they worked. We use that information to calculate hourly wages. We determined whether somebody was earning more or less than $15 an hour. That was our low wage cutoff. And we calculated that share, by overall, it was something like 30% of workers in 2018 in the American Community Survey, and we did that by race, by education, by gender. So I'll review that, and we're going to use that as a basis for what we do next. So what we'll do, in addition, the new stuff that we'll do today are items 2 through 5 on this list. So we are going to, I'm going to show you how to transform variables in your data that are when kind of conditions are more complicated, when you want to create a new variable that corresponds to a lot of different what are called if or if-else conditions, and I'll explain what that means. After we do that, we are gonna, number 3 on the list is kind of like the meat of data analysis and using statistical software like R. So what we're gonna do is we're gonna learn how to combine and transform data sets. This is, I think, a notoriously kind of tricky area for people who are new to statistical programming, but it is really, and it is kind of difficult, I admit, but it is really kind of like one of the key sets of tasks. So we're gonna learn how to stack, join, reshape data. These are known as like merging or appending or binding. So these kind of verbs where we combine different data sets or transform the layout of an existing data set. That's what we're going to do in item 3. After that, if we have time, I'm not sure if we'll have time, but we'll see how it goes. We're going to try to do a more complex analysis where we use that American Community Survey data and we use geographic information in that data to calculate county level statistics. This is actually a little complicated using the American Community Survey because there is not a county level, there is no county level information in that data. So we have to kind of approximate county level geography, and I'll show you how we can do that. Finally, the last thing that I want to cover is, when you start doing these kind of data analysis tasks, you start having like lots of files, lots of directories got to keep track of. I want to give you some tips about how to manage your project in RStudio so that you can kind of keep your files straight, know where things are, and know where you're loading inputs and saving outputs. So that's the outline for today. Let's go ahead and get started. I'm going to open up RStudio. So RStudio, this is kind of what RStudio looks like when you open it, if you're familiar with it from last time or from your other work. I have this script loaded from this data page, ACS wage analysis last time. That's on the left-hand side. This is our, R script window. This is a script, we can run the whole thing or run selections of it, and it pops up down in this console window on the left. And then on the right-hand side, we have this environment window, and on the bottom right, we have kind of like a file browser, a help window, some other information. So that's the basic layout of RStudio. I got to change this layout. I want to show you how you can change it. Also, it's a little difficult on my eyes to do it this way. So you can kind of change your layout, make it different colors. I want to make it darker so it's easier on my eyes. The other kind of important thing that I want to show you is that in the pane layout, you can change all these panes. So this can be particularly useful for you in RStudio when you're only focusing on certain kind of panes. And so what I'm going to do is I'm going to put the console in the top right, and I'm going to put the environment in the bottom left. And you can kind of click on these things and change the order. It doesn't change the content of your analysis, but it changes where things are located. And that's going to make it easier for us to follow along what's going on, because I'm going to use mainly 2 windows today. That's the console window that I've put on the right and the script window that I've put on the left. So I'm going to type code into the left and run it on the right. Sometimes I'll type on the right. I'm going to highlight things and press Control Enter or copy and paste, and that's going to send stuff to the console on the right. So for example, this stuff that we did on the left-hand side is what we did last time. This is analyzing American Community Survey data. So like before, we loaded a set of packages. We loaded the tidyverse package that gave us a lot of functions to manipulate data. We also loaded the Haven package that gave us a function particularly to load stata data files. So I've saved these data files in my downloads directory, just like last time. So I'm gonna load the ACS data, and it's going to think for a second, and then I can type ACS in the right-hand side, and I'll get the ACS data. So this is just like last time, this big data set of 2018 American Community Survey data, about 3.2 million observations, and we had 13 variables in that data. We cleaned up that data to calculate hourly wages for workers. What did we do specifically? We made sure that we were only dealing with workers, people who had valid values of income. We made sure that they had some, they actually worked some hours during the week. We made sure, and one thing that I'll change today, but one thing that we did is we kept full-time workers. I don't know if you remember, but in the ACS data, you don't have very detailed information about how many weeks people worked over the last year. You have these kind of course categories. To make things simple, last time we kept workers who worked about 50 to 52 weeks a year. I'm gonna relax that this time, show you how you can change that, but that's what we did last time. We restricted the analysis to Virginia, just the state of Virginia. You could do it for your own state. We'll relax that again. We'll do it for a variety of states this time. We'll also do it for different geographies like counties, hopefully. Finally, the last kind of like manipulation of the data before we did the analysis is we calculated people's hourly wage. So we calculated their wage as their income over the last year divided by the total amount of hours they worked over the last year. And what we did is we multiplied their hours per week times an approximation for how many weeks they worked last year. That gave us an hourly wage. We defined people as low wage, being less working, having an hourly wage less than $15 an hour. And then we, so let me just run that code. So I'm gonna highlight that code, press Control Enter, and that runs the code in the console on the left. And then I have an object you can see down on the bottom left-hand screen of, bottom left-hand side of the screen is ACS clean. That's the kind of cleaned up data with all the new variables that I've added. So if I click on that, it pops up in my window here and as a data browser, and you can kind of look at the different hourly wages or inspect the variables that you created. Finally, we did some analysis. We calculated the mean of this low wage variable. So we calculated the share of workers who are earning low wages in Virginia. That was about 30%. Remember, that was a weighted mean. So we took the mean of the low wage variable, but we made sure to use the sample weight. And then finally, we did that for kind of different breakdowns in the data. We did that by gender, and I think we did that by race. Maybe we did some other things. Just to show you how you could use this group by function to group your data before using a summary statistic so that you get the summary statistic for each group, whether that group is gender, race, education, whatever you're interested in. Okay, so that's basically what we did last time. Now, what are we gonna do this time? All right, so let's talk about recoding new variables using what are called if or if-else conditions. So let's do kind of two, broad tasks. First, what I want to do is redefine the race category so that it identifies Hispanics. So right now in our race variable, so let's look at our race variable. So we can run ACS clean through the count function and calculate and look at the different values of race. So what did I do just here? I took my data set ACS clean, which I created over on the left-hand side and is now in my environment. And I pipe it, I hope you remember this pipe function. I piped that ACS clean data set to an input to be an input to this count function, and then I counted the race variable, or tabulated or cross-tab, provided a frequency table for, these are all synonyms, for the race variable in the ACS clean data set. And that's what it looks like. And if you see this race variable, it has white, it has black, it has American, Indian, Chinese, Japanese. There's no Hispanic here. And the reason why is that in census data put out by the census, they ask kind of two sets of questions about your race or ethnic identification. They ask what they call what people's race is, and people self-identify according to categories like these. Then they also ask questions about what they call your ethnic origin or nativity. And that is the kind of information, that separate information about ethnicity is where we can gather information about how people are commonly defined in data as having Hispanic ethnicity. And so there is another variable in the data set called Hispan. And that has information about Hispanic ethnicity, in the sense that it has information on people, when people identify as either being from a certain group of countries or having their origin or their ancestors from a particular set of countries. And you can see these kind of coarse group of countries that they have, that IPUMS, who's recoded this data, has for Hispanic ethnicity. And just as a reminder, so you can go to the IPUMS website. This is where I downloaded this data from. So this is the IPUMS USA website. You can select samples. And in particular, I selected, I don't know if you can see this, I selected the 2018 ACS. And in that data, there's information on people's demographics. And here we go, race, ethnicity, and nativity. And so there's a race variable. That was the variable we were looking at. You can click on codes and see all the different codes that are in the data. You can do the same for the Hispan variable. That's where you find information about these variables. Okay, so what we want to do is kind of a common way of recoding race variables is and EPI does this a lot, is to combine the race and Hispanic ethnicity variables and create like basically an aggregated or a very broad race variable. And what I want to do is create a broad race variable. Let me switch back to my slides. That is much more coarse, has only a few categories like white, black, Hispanic, and other Asian and other races. So I want to make it more coarse, and I want to make sure to include Hispanic origin as part of that race variable. So that's one thing that we're going to do. So we'll do that next. Right after that, we are going to do another kind of recoding of the data to use, so that we use all workers rather than just these workers who work full throughout the entire year, worked 50 to 52 weeks. That's going to be another kind of like recoding of the data where we create a variable according to some different conditions. Okay, so let's work on this Hispanic variable first. So I'm going to clear my console just so you can see things a little easier. So in our ACS clean data, again, we have this Hispan variable. It takes values 0 through 4. It has 5 different values. It takes 0 through 4. And if I wanted to create a new kind of 0, 1 Hispanic variable, whether somebody's Hispanic or not Hispanic, a common way of doing this with this data, or kind of conventional way, is to categorize people as having values 1 through 4 as being Hispanic, and value 0 being not Hispanic. Okay, so the way that we do this in R is we use the mutate function. So we're going to pipe our data, ACS clean, to the mutate function, and we're going to create a new variable. Let's call it new Hispanic. And it is going to equal something. And one way of doing this is to use what's called the if-else function. Okay, so this is a new function. So this if-else function has 3 inputs. I don't know if you saw this little pop-up when I was typing this thing. RStudio is telling us, hey, if else has 3 inputs. The first input is a logical condition that we're going to test, whether or not we think somebody is Hispanic. The third input of this function is what value do we want to assign the new variable Hispanic when that condition is true. And so that's the second variable. The second input, the third input is what condition we want to assign this variable when that condition is false. So I know that was a little hard to understand. Let me write it out, and then we'll walk through what I'm going to walk through the logic. So one way of doing this is let's code people as Hispanic if they have values Hispan between 1 and 4. We're going to give them the value 1 if that's true, and we're going to give them the value 0 if that's false. So that is that. Let's just see what that looks like. And one way we can see what that looks like is compare that to the old value. And so let's see what this new Hispanic variable is that we've created. So as you can see, it's a 0, 1 variable. It's 0 when Hispan is not 1 through 4, and it is 1 when Hispan is 1 through 4. So that's a very simple way of kind of recoding something according to some conditions. So let's go ahead and add that, to add that code to our analysis on the left, because we're going to use this Hispanic variable as we refine our race variable. So now when I run this code, I'm going to get a new Hispanic variable created in my ACS clean data set. Let's go ahead and integrate this new Hispanic variable, this 0, 1 variable that I created, into a new race variable. So I will go ahead and make some space to type some code. So, before we had in the original race variable, let me clean my console, we have, the following groups of races in the data. So we can recategorize these. A common way of recategorizing these is throw everybody who identifies themselves as white, throw everybody who identifies themselves as Black or African American, we'll call them Black, and then create a kind of create an Asian race, create an other race, and then create a separate Hispanic category within our races. One common way of doing this in R, that's a complicated set of conditions. Let's create a new race, let's call it new race, I guess. One way of doing this is to use what's called the case when function. So before we use the if else function, that allowed us to handle kind of a simple set of logic. The case when function will allow us to handle much more complicated logic. The way that you use case when is that you write down a list of formulas, and in particular and those formulas on the left-hand side are going to be our logical condition, and on the right-hand side they're going to be the values that we assign new race. So here's an example. So when race equals 1, what I want to do is create a value for new race that's equal to, I'm going to call it white. So I'm just creating these. Before we were creating kind of like numeric categories. Here I'm going to create what are called characters or strings. Then I'm going to have a comma to indicate that I have a new condition. And when race is equal to 2, I want to call those people in my data, for shorthand, I'm going to call them Black. When race equals 3, American Indian, there aren't that many American Indian people in our data, so we're going to aggregate them with some other categories. At least in Virginia, there aren't that many in the ACS. We'll call them other, and then we will create an Asian category combining races 4, 5, 6. So when race is greater than or less than or equal to 4, and less than or equal to 6. I'll create an Asian category. And then finally, the last category where we have people who identify as an other race or multiple races. A common thing to do is to categorize them as other. We could make this much more detailed or much more coarse, or we could use kind of other race variables to kind of break different multiple races out, but I'm just trying to keep this simple. This will give us a new race variable. So what will this look like? And I'll compare this race. I'll compare the old race and the new race. And you'll see the old race, the first column on the left. You'll see the new race in the middle here. And you'll see how multiple categories get assigned a single category. Okay, so case when can be very useful. Finally, let's modify this case when one to actually include Hispanic ethnicity. So if we wanted to create a new, in this case, a new value for our variable new race called Hispanic, what we can do is when Hispanic, we'll add this. Yeah, so I'm going to add this to the very top, and I'll explain why. When Hispanic is 1, I'm going to assign people a value Hispanic. So let me just go ahead and run this code. And then let's investigate our data. So ACS clean, I've created a variable called new race. Let's look at that compared to Hispan, race, and new race. Let's look at all three of these things. So here is Hispan and race are original variables. And here is our kind of aggregated or combined variable that we used case when, the function case when, to define. Okay, so as you can see, everyone who let's probably be easier to see this if I show all the rows. Everyone who identifies, who is defined as Hispanic, according to my classification of Hispanic, oh, I didn't do this right. Let's do this. I need a new Hispanic there. Let's try this again. Okay. Everyone who is identified as Hispanic, according to my new Hispanic definition, gets a Hispanic race value. And then I have these other kind of aggregated course values for new race. So this is one way that you can create kind of a simple aggregation of variables according to conditions from other variables. So our new race variable just takes 5 values and kind of combines information from multiple variables. Somebody asked, is tilde another way to assign a variable? So what you're referring to are these tildes in this kind of like list of conditions here. Basically, the tilde is just kind of a required part of when you type when you're using the case when function. So case when is a function, and it spits out a kind of recoding of variables. And the way that it does that is it takes a particular set of inputs. It takes a list of what are called formulas in R. And a formula has the following structure. It has something on the left, then a tilde, and then it has something on the right. The thing on the left for case when is the logical condition that you're testing, whether new Hispanic is equal to 1, or whether race is equal to 1, or whether race is between 4 and 6. Okay, so those are logical conditions. They're true or false. When those conditions are true, case when assigns the value that you type on the right after the tilde. Okay, so that's the value that you're going to end up assigning to the variable. Another feature of case when is that it is what's called an if-else condition, or it assigns using what are called if-else logic. And what that means is that it checks logic in the order that you type it. So specifically, it checks the condition first. The first thing it does is it says, is new Hispanic for this person equal to 1? If it is, I will assign them the value Hispanic. Then, if that condition actually is false, I will move on to the next conditions. Okay, so I will check whether race is equal to 1. If it is, I will assign the value white. If race is false and also new Hispanic, if race is not equal to 1 and also new Hispanic is not equal to 1, I will check the third condition. So that's kind of the logic of case when. It's an ordered logic, so the order that you type things matters. And then also it takes a very particular syntax of writing these formulas where you have something on the left, that's checking a logical condition, and then you have something on right, that's the value that you want to assign. Okay, so we can expand this kind of logic to that calculates like a new race variable. We can use that, to perform our kind of like an analysis of low-wage workers by race in our given state. We can also, change some of the other inputs using the case when function to account for a more complicated logic that we have, for example, with weeks worked. So let me switch back to the IPM's website and let's look at the variable for weeks worked. So that's in the person, work, category, weeks worked 2 is the name of the variable. And so these are the kind of the values in our data for how many weeks people have worked the prior year. And as you can see, they get values 0 through 6, and whether someone you didn't work, or whether somebody, your value of 1, whether somebody worked 1 to 13 weeks, and so on. So we have this kind of like binned data. Before, we only kept values equal to 6. So if people worked 50 to 52 weeks, and we just said, hey, on average, they work 51 weeks. So we can do that kind of same logic for all of these different values. So what do I mean by that? So just to be clear, in our ACS clean data, we only kept people who worked 50 to 52 weeks. And that's through this filter operation right here. So let's relax that. Let's get rid of that. And let's create a new variable called weeks worked. And again, use this case when function. And to assign people a value of weeks worked, depending on what their values were, those aggregated values. So let's review what they were. They range from 0 to 6. So we're going to assign a value of 0 weeks worked when weeks worked 2 is equal to 0. Let's assign when weeks worked 2 is equal to 1. We're going to assign an average of the 1 to 13 weeks. So on average, it'll be 7 weeks. So I'm just writing the average on the left-hand side. And we can keep doing this for the other values of weeks worked. And this will allow us to use all of the information in the data. It's going to be an approximation, but it's kind of the best we can do for a simple analysis. Other things that you could do, or that if you had, another data set, like for example, the March CPS has more continuous values of weeks worked rather than these binned weeks worked. you can kind of use the relationship and the data between, demographic information and what industries people work in, and kind of predict how many weeks somebody works in a given bin and apply that prediction to this data. But that would be kind of complicated, but that's something EPI has done in the past. So let's make sure that this code actually runs. Okay, it does. So I created a new variable weeks worked according to these conditions. Somebody asked, what is the command to print a whole tibble in the console? Great question. So the you wouldn't want to do this with this gigantic data set, but before we were kind of like looking at this data set that had like 39 rows. By default, R is only going to print out part of the data set as an output, just to, so that it doesn't scroll on by and you have no idea what's going on. It'll print the first 10 rows. There are two things that you can do to relax that. One is you can tell R to print however many rows you want. So you could say, I actually want you to print 20 rows, and it'll do that. Or you can say, print all the rows, and you type print infinite number of rows, INF, capital I, lowercase nf, and it'll print the whole data. The other thing you can do is you can use the capital view command. You type that, RStudio will load your entire data in the little data browser over here. So that's exactly the same thing as clicking on a data set in your environment and having it pop up in the data browser. So those are two things you can do that are really useful when you're exploring data, when you want to look at like more than 10 rows of data, or your data set's kind of big or something. You can use the print command like I showed you. Here. Or you can use the view command or click on the object and see the whole data set in the data browser. Okay, so where were we? We created this new weeks worked variable. So what does that now look like? So I'm gonna compare the old weeks worked variable with the new one. And you'll see here's the old one on the left. These kind of values 1 through 6, they correspond to these labels, 1 through 13 weeks, 14 through 26 weeks, these bins data. And the new variable that I created, which is an average or the midpoint of those bins, 7, 20, 33, and so on up to 51. So that gives us an approximation of weeks worked. We can incorporate that into our analysis. And let's see, so we create weeks worked, we restrict the results to Virginia, then we define the hourly wage. So before we were taking wage equal to wage income over the year divided by hours worked times 51. So that 51 was coming from, we kept only people who worked throughout the full year. Now we can relax that and change that to our continuous weeks worked variable, or sort of continuous weeks variable. And we can redo our analysis. So I think before, let's just see how this changes things. Before we had a output that looked something like this. Yeah, so before, when we calculated the share of low wage workers, we got 29.7% of workers were low wage workers. Now remember, that's with keeping only people who work throughout the full year. So those people tend to have higher hourly wages. So when we relax this condition, we should get a higher value, a larger share of low wage workers. So let's go ahead and run this, run this analysis again. And then rerun our main summary statistic. And as you can see, we get a higher share. We get 35.7%. So about a third of the workforce in 2018 in Virginia was low wage, according to this like $15 mark. Great. Okay, so that calculates, that showed us how to recode variables according to if conditions. So we use these functions if else and case when. They're super useful. You'll use them all the time if you're recoding conditions. We use them to kind of just relabel things, like create a new race variable, but we also use them to incorporate multiple variables into a new variable and kind of generalize a variable that was kind of binned into one that was a little more continuous. Okay, so the next thing that I want to do is learn how to, that was creating new variables. That was, you know, more complicated ways to create new variables. Now what I want to do is show you how different ways of combining data sets. So here, let's do 4 things, and they're all going to involve using exactly what we've done before, but now taking data sets that we create and combining them in different ways, or transforming them in different ways to show a kind of a different layout that's easier to understand. So let's do 4 things. The first thing is, before we had created kind of like overall shares of low-wage workers, and we also created race-specific shares of low-wage workers. Let's create a single data set that contains both sets of information. So we're going to combine two output data sets that we create, statistics by race and statistics overall, and create a single new data set. And to do that, we're going to stack data together using what's called the bind rows function. The second thing that we're going to do is, you know, the only summary statistic that we've been calculating really so far, other than some tabulations, is the share of low-wage workers. So what I want to do now is show you how to add more summary statistics. In particular, for this kind of exercise, it'd be really useful to know, like, you know, what is the size of the population that we're talking about? Like, how many low-wage workers is this? When you say, you know, 35.7% of Virginia are low-wage workers. Also, it's going to be very useful to calculate sample sizes. We don't want to be calculating statistics when the sample is extremely small because they may be very noisy or unreliable. So I can show you how to do that. After those 2 things, it will be useful to compare how our state, in this case Virginia, compares to the US overall. And so we're going to calculate statistics for Virginia, we're going to calculate statistics for the US overall, and combine those results. Finally, if we have some time, I'll show you how Virginia compares to not just the nation, but how it compares to other states. And so there are a lot of other states. We're going to pick nearby states in Virginia, the states that border Virginia, and you know, create a data set of output and, you know, reorganize the layout of that data using what's called the pivot wider function, or what are sometimes called reshape functions. So let's go through all 4 of those tasks. So the first task, if I can remember it, oh yeah, create a single summary data set with race-specific and overall shares of low-wage workers. This is pretty easy, but it's very useful. So let me clear my console window so we have a little space. And let's look at my analysis code down here. So my analysis code before was calculate the overall share of low-wage workers, and then calculate the share by race. I'm going to change that to use our new race variable to make things a little tighter. So here are the shares of low-wage workers by our new race variable. And I want to combine these 2 data sets. I want to stack them vertically, stack them on top of each other. So this is really easy to do, but it's very useful when you're preparing lots of complicated output. So the first thing that we do is I need to name these objects. So I'm going to call this like results overall, and run this. And so now, I don't know if you can see this in my results window, I have this results overall object. That's just like a single boring data set that shows my results overall. And then I have a results by race that I want to create. So what am I doing here? I'm naming an object. I'm assigning it and assigning that object something using the assignment arrow. And that the thing that I'm assigning is basically another data set. So I'm assigning a data set to an object that stores that in my environment in R so I can access it later. So let's run the results by race. And let's just make sure that we know what we're doing. Perfect. So this is results by race, and this is results overall. So let's stack these together. The way that you stack things or combine things vertically is you use what's called the bind rows function. So bind rows takes several inputs. It just takes the data sets that you have as input, and it will stack them together. So let's stack them together. And when I do that, I get I took two data sets as arguments to the bind rows function, and I got a single data set as output. So what does that new data set look like? As you can see, it literally just vertically stacks these two data sets together. So I have and it preserves the columns in the data set. So my first data set results race had two columns, this new race and then this weird weighted mean column. And then my second data set results overall only had one column, just this weighted mean. When bind rows stacks the data, when R stacks the data like this, it binds the data sets together. It has a new race column, as you can see. There's Asian, Black, Hispanic, other white. And then there's this NA, this missing NA. That's coming from this second data set where there is no new race column. So R assigns it what's called a missing value or an NA value in R. NA is how R categorizes what are called missing values. Stata, for example, uses like a period or a blank. Other statistical programs use different symbols. R uses NA. And then on the right-hand side is my final column with the weighted mean. And you can see the overall value and the race-specific values. So let's go ahead and add this to my script over here. And let's take care of this missing value. So the way that we can recode this missing value, let's say we wanted this to say overall, it's not exactly a race, but we're comparing statistics within races to an overall, all races. So if I want this NA to be called overall, I will mutate my new race column, and I can use that if-else function again, okay? And the test that I'm going to use is that what I want to do is I want to say, hey, when new race is NA, I want it not to say NA, I want it to say, let's say overall. The condition that we're going to use is the is.NA condition. So when new race is NA, that's what this condition says, I want to assign the value overall. And when it is not is NA, when it is not missing, when it is not NA, I want to assign it just whatever new race is. So let's look at what this output is, and I'll explain it again. So when I run this with this mutate new race, you can see that the NA has been replaced with the overall. So what has happened? This is NA function is how you identify whether something is missing or not in R, okay? So if you want to identify whether something is missing or not in R, you're going to use the is NA function. For example, if you wanted to, this is wrong, but if you wanted to change this to say, hey, another way you could write this is like, when things are not missing, and I'm going to use this exclamation point, that means negate or not true. When things are not NA, when new race is not NA, I want you to use new race. And when things are NA, when the is not NA is false, I want you to use the value overall. So this will give the exact same output as before. These two kind of statements here are logically equivalent. One, the test is new race missing? And the second, the test is new race not missing? So that's how you can both stack results, but account for the fact that when you're stacking different data sets, you may have different kind of columns in your data. Okay, so that shows us task one. Create a single summary data set with race-specific and overall shares of workers. Okay, let me go back to RStudio. Let's do the second task, which is to add a bunch of summary statistics. Or is that what it is? Yeah, add a bunch of summary statistics. So what is the easiest way to do this? So let's look at our results overall data. That'll be the easiest thing. Let me clear my console so you have a little room. Okay, so as you can see, when I have this results overall, there's a column in the data called, it has this little quote sign, and then it says weighted.mean, low wage, per weight. That's coming from my summarize command. It's telling me what I summarized. So what you can do to make this column a little nicer, and we're going to use this when we add multiple columns, you can rename that column on the fly. So let's say that we wanted really that column to be called low wage share. What we do is in the summarize command, we type the name of the new column that we want, that's column name, and we type then equals, and then the function, the summary function. So before we just typed the summary function, and the column name was that summary function. Here we want to give the summary function a different name. So when we do that, we'll get a nicer looking name. It could be any name, but that's the one I picked. Now that will allow us, so let's put that code over here. Now this kind of like general code here will allow us to add multiple summary functions. So here's how we can add another summary function. Instead of just having the low wage share, we can have, for example, the total population in the data. So the total population, let's call that total population, I guess, or total pop to make it short. That will be the sum of the weighting variable. So each person in the data corresponds to, is weighted, or in the sample of data corresponds to, a number of people in reality according to the census. That number of people is this person weight variable. And I'm just going to add those up using the sum function and create a total population. So when I run that code, I get my low wage share column, but I also get this total population column. I get 4.5 million. That corresponds to the number of people with valid hourly wage values in the ACS data. Virginia's population is like 8-something million. About half of that population is actually working because they're not too old to work, or they're not children. That gives us that 4.5 million. We can additionally add more summary statistics, like maybe we don't care so much about the total population, but we want to know the low wage population. To calculate the low wage population, again, we're going to add things up in our data. We're going to add up whether or not somebody is low wage or not. That's a 0-1 variable, times that person weight. So this formula here is going to get a 0 when somebody is not low wage, and it's going to get a 1 times the person weight, and add those all up when that person is low wage. So let's go ahead and calculate this. And you can see that we have, 1.6 million low wage people. And so, just to check to make sure we're doing this right, if we divide these two numbers, the low wage population by the total population, we'll get something pretty close to what we have for the low wage share, 35.7%. Finally, let me show you how to create a sample size variable. Let me just write this down. So I'm going to create a new variable called sample size. If you want to count the number of rows in your data, the function that you want to use is called n. And so n doesn't really take any input. It's just n, and then you put parentheses. Show you what this looks like. And so we can see in our data that the total sample size in our data is about 44,000 people. So there are 44,000 people, and let's just like confirm that that makes sense. If I look at the ACS clean data, which has been restricted to Virginia, here's that number again. 44,000 rows, 44,000 people in my sample size. All right, so we can just go ahead and, nice thing about code is you can copy and paste. I'm gonna copy and paste and do those statistics by race. So I'm gonna group by new race again. So now I have my results overall. I have my results by race. And then I can bind rows again. And you can see that I've created this new stack data set that not only has all my races that I categorized according to the new race variable, it has the overall, and additionally, it has all these new columns that I created. So that's how you can create new columns using Summarize. That's how you can stack data together. That takes care of tasks 1 through 2. Okay, in the remaining amount of time, I will go ahead and let's just keep going, and I will show us how we can compare Virginia to, let's just go ahead and compare Virginia to the US overall, because that will allow us to learn about how to merge or join states together. So how does Virginia compare to the US overall? So we'll go back to the same code. We're just going to use all the same code as a basis for this entire analysis. So let's change our code just a little bit. Here we have this line in our data cleaning exercise where we restrict the analysis to Virginia. Okay, so I'm gonna drop that analysis, drop that restriction, and rerun. I'm just gonna rerun everything. So to rerun everything in your do file, you could highlight everything, copy and paste. You could highlight everything, press Control Enter. The other thing you can do is press Control Shift Enter. It will run the entire file. And when we run that, we get a new set of results that's slightly different than last time. You'll see that all of these numbers are different. In particular, these population numbers are much higher. That's because this is for the entire United States, okay? Because I didn't restrict to Virginia. Now that's gonna allow us to do things for the US and do things for Virginia separately. So let's go ahead down here at the bottom and do things for Virginia. So we're going to create a new object. We'll do this by race. So we'll take our ACS clean data. We'll group by new race, just as we did before. Why don't I just go ahead and copy this stuff? And to make things simple, maybe I'll get rid of all these extra summary statistics and just do low wage share. And to make sure that I'm doing this for Virginia only, I'll restrict the data to Virginia. So this will give me the results by Virginia, for Virginia by race. I can do this for the US overall. That means it's the same code, but I will just not restrict to the US. And let's do also, let's do the kind of the overall. So not by race, but for overall for Virginia. And let's do the same thing. Let's do the same thing for the US. Okay. Great. And so now we can use kind of our binding commands, and we can bind the Virginia results together. So we can stack these Virginia results together. And so what does that look like? Oh yeah, so I do need that code, that little bit of race overall code. So this is what our Virginia results look like. And I can do the same thing for the US. So we'll just change this to US. There we go. So here's the US results. And I need to make sure that I name these things. So results, Virginia, I'll assign them values and assign these values. Great. Okay, so now we have results for Virginia and the US separately. Let me rerun these so they're all in my environment. So sometimes when you type stuff, RStudio will try to auto-complete it for you. So here's the results for the US. Here's the results for Virginia. And so what I want to do is I want to show you how to combine these data sets together by combining them horizontally. Before, in the intermediate kind of steps here, we combined multiple results data vertically. We used the bind rows command. To combine data sets horizontally, we're going to use what's called a join command, in particular the command full join. So what the easiest thing to do is I want to distinguish these data sets by, I'm going to change this low wage name here in the US data set to I'm going to change it to just call it US. And I'm going to call this low wage share in this Virginia data set, I'm going to call it Virginia. And then that's going to distinguish, just these column names are going to distinguish these two data sets, and it's going to allow me to combine them together. So here's what I mean. So in the Virginia results data set, let's change let's use the, what's the easiest way to do this? The easiest way to do this is change these summarized commands to, let's call it Virginia. I'll use the abbreviation Virginia, and then change these to US. US. And so now let me just rerun my analysis just to show you what I have. Here's the Virginia results. Here's the US results. So you can see all I've done is just change the name of this column. Now we can use the join command to combine these data sets together. So it's very simple. One join command that's very common is the full join command. That's going to combine, it's going to match rows in this data. How is it going to match rows in the data? Well, if I just type two data sets, results US, I'll show you what I mean. It puts these data sets together horizontally. It matches Asian with Asian in the Virginia and the horizontal data set, in the Virginia and the US data set, and puts the appropriate values in the right columns. So this is what's called a merging command, or a joining command, full join. Another useful command, while we still have a little bit of time, is, right now this column name is called new race. Another way you can change column names is use what's called the rename command. So I'm going to call this, because I have this overall category, it's not really a race. It's just, a group of individuals. So we'll just call this new column, instead of this column being new race, let's call it group. There. So now we have a relatively, you know, simple data set as output there, where we combined multiple data sets by stacking things vertically, and then we combined multiple data sets by stacking or merging them or joining them horizontally. All right, in the final minutes before questions, the last thing I want to do is show you how you can compare. This is a kind of a common thing to do, is to compare your state's results to like other nearby states. So let's maybe the easiest way to do this is maybe the easiest way to do this is get rid of this kind of like Virginia. Yeah, let's get rid of this kind of Virginia results. So, and I'm gonna do this, yeah, okay, sorry, I'm trying to make this as simple and as quick as possible. Let's use this for, let's just do the overall shares for Virginia and compare them with other states. Okay, so how will we do this? So our ACS clean data, it has all the states in it so far right now. So you can see the state identification variable is state FIP. It has, you know, 51 possible values. We were looking at state FIP code equal to 51, just a coincidence, and that happens to be the FIPS code for Virginia. The way you can look at state FIPS codes in our data is to go back to the SIPM's website, and let's look at household geographic state FIP and the codes. Okay, so here are all the states. Here are all the states, and what do I want to do? I want states that are near Virginia. So what borders Virginia? Let's see, well, Maryland, North Carolina, Kentucky, Tennessee, Virginia, of course. Might have missed one, but I think that's right. Oh, West Virginia, of course, West Virginia. So let's, instead of filtering the results to only Virginia, and let's do this for different states, let's create a new variable that's going to allow us to, you know, really hone down on that selection of states. So let's create a new variable called state ab, and it's going to be equal, we're going to use the case when function again, and we're going to create a new state variable. So for Kentucky, we'll call it KY. We'll create a new one for Maryland. New one for North Carolina. Virginia, of course. West Virginia. And finally, Tennessee. Okay, and we will restrict our data. Let's go ahead and restrict our data to just those states. So one way is we can filter our data and again use this. So what am I doing just to review? So I'm taking my data, I'm creating a new variable called stateAb. So what does stateAb look like? When I do this, it is going to create these variables, create this variable stateAb that has these values ky, md, and so on, and then also missing for all the states that aren't in this nearby Virginia category. So I want to filter out these missings because I only want to look at nearby states. So I'm going to filter out NA. So I'm going to keep everything that is not NA for stateAb. And then I am going to group by stateAb and summarize my data just as before. So what does this look like? Hopefully this code will work. Great. So this shows the results by stateAb, low wage share for each of these states. We could make this more general. We could group by, stateAb and new race. And you can see that we get this larger data set where we're using multiple groups where we have a long kind of data set for stateAb, Kentucky, and all the different races and all the different values associated with those races. So let's look at that in the data viewer. And so you can see all of these values by race, by stateAb. Now this data set, the way you would describe this data set, it's long in state abbreviation and new race. It's kind of, it's very useful for, the format's very useful for analysis, but it's really hard to actually read. One way that we can, change that is we can use what's called a reshape or a function. And so the specific function that we want to use is called pivot wider. So what does pivot wider do? Pivot is going to take this long data set that has 30 rows and convert it to a data set that's more wide. It's going to have fewer rows and more columns. So this is one of the more kind of complicated commands. It takes a lot of different arguments. In particular, it's going to take an argument called ID columns. In this case, that's going to be my, let's say I want to make this data set so that, the state abbreviations are kind of like columns and the new race is the rows are races, basically. So what I do is I create I use the ID columns argument of pivot wider. That's going to be new race. And this is a little confusing at first, but you'll kind of understand it when you see the results. I'm going to take the names, then it requires a names from argument. And those are going to be the state ab. And then it's going to take a values from argument, and that's low wage share. So what does that look like when I'm done? So here's my original data set. It's this long thing. Now here's my kind of widened data set. I took this long data set and it moved, it kind of, these are kind of things that you would do in Excel with like pivot tables. It took, or transposing data. It took all of the state abbreviations in the long column and kind of transposed them and moved them to new columns on the right-hand side. So that's the pivot wider function. There's kind of the opposite of pivot wider, that's pivot longer. These are kind of complicated functions, but they're very useful for regrouping output. You can look at the help manuals by typing question mark, pivot longer, or pivot wider. We used pivot wider because we were going from long to wide, and it shows you all the different kind of arguments that that you need to include, and gives us a variety of examples. So that's what's called a reshaping function. All right, so it is 4:15. We are almost out of time, and I want to have some time for more questions. We did a number of specific tasks. In particular, the last set of things that we did, we learned how to combine data sets by either stacking things vertically or combining them horizontally, using bind rows to stack things vertically, or combine things horizontally. We used the join functions. And finally, we learned how to kind of transform or reshape data using a pivot wider function. Okay, so I want to leave time for questions. So does anyone have any questions? Things that I did that were especially confusing? Somebody asked, do you have a final version of the code somewhere? Yes, I should have put it on this. I guess I didn't put it on this website, but I'll do that after we're done. Absolutely. Any other questions?
I have a couple of questions. First, if you're joining data with a numeric variable to link them, like a person number, do you have to sort the data first, or does that command automatically sort? I think you're muted.
So sorry. Yeah, that's a great question. You do not have to sort the data.
Okay.
If you are combining data sets, let me share my screen. If you are combining data sets, so where did we do the join? Full join command. So if you're combining data sets using the join command, and it is not transparently obvious which columns R should match the data set on, you need to tell R to match the data set on a specific set of columns. Mm-hmm. So that's the only kind of like trick to the join command. So for example, we join data sets by like doing something like this. Join commands take another argument called the by argument. And here you're going to type, the columns that you want the data set to be joined on. Sometimes you don't actually have to type that. We didn't have to type it because our data sets were pretty simple, but that's the only kind of like extra bit of information that you're sometimes going to need to provide R. But you don't need to sort the columns ahead of time. That's the nice thing about the join command, is it is going to match these two data sets on the by variables that are painfully obvious when you're joining them, or if they're not obvious or there's some ambiguity, what you tell it to join on.
And the second question I had, if you're joining, say, a person level file to a household level file or aggregate file, yeah, is it the same command, or is there a different command you need to use?
Yeah, so that's a good question. I only covered one of the join commands. The answer is yes and no. So you can think of, when you're joining data sets, you have a data set on the left, and or I don't know what's left and right for you guys, but you have a data set on the left and you have a data set on the right, okay? And you're gonna join them based on particular columns, okay? Full join, what full join does is it says, let's say you're joining on like a household ID or something like that. Full join says, I'm going to join on all matching household IDs that I find, and I'm also going to join even if I don't find a matching ID. So I'm going to include household in my output data set, my join data. I'm going to include households that I couldn't find a household ID on the right from. There are other commands like left join and right join that are more restrictive, that will drop rows or observations when it cannot find a match. depending on whether the data set is on the left or whether the data set is on the right, depending which command you use. Full join keeps everything. In our example, there were no unmatched kind of rows, so it wouldn't matter whether we used full join, left join, right join. Inner join means only keep things that match in both data sets. Anti-join means keep things that do not match at all. So if you look up, you know, in your help files or on the web, if you look up join, tidyverse, or full join, left join, right join, you'll find all the different join commands. Yeah, I think that might answer your question.
It does, yeah, thank you.
That's a good question, thank you.
Mm-hmm.
Oh, and Zane included like a very helpful visualization of all the join commands, yeah, in the chat. We have 8 minutes. What, any other questions?
Is there a raise hand or do I just?
Go for it.
All right. So I'm just wondering, since we didn't get to the project management part, if there's like a good resource that you can like send a link to just for best practices, because I always wind up with a pile of files that's.
Yeah, I totally agree. Sorry, I ran out of time. Let me cover that in like a couple of minutes. That's a great, thank you for bringing that up. Okay, so the problem is, you know, the more complicated your project, you start to just have like tons of files. Like for example, so in our analysis, what do we have? We have a data set that we're using. That's a file and it lives somewhere. In my case, it happens to live in like my downloads directory. Okay, maybe it lives in some other place on your machine, but that's where I downloaded it. I also have this file, ACAS, you know, wage analysis last time.r, you know, that lives in a particular place. And so, you know, often what you want to do is you want to keep your files in your directories straight. Another kind of like so that's one, you want to do that because you have like a bunch of different files. Another kind of reason why you want to do that is that by default, when you type in a file name, like, okay, so when I typed in this file name read_dta and I gave it this full path, you know, your path's going to look different, but that's my path to this file. It shows what directory it's in and then the file name. If I didn't type that directory name, so let me just type this in the console. If I didn't type that directory name, so when I do type that directory name, Stata knows, you know, what that directory, I mean, R knows what that directory name is and it finds the file. If I didn't type that directory name, R would have no idea where that file is. Because by default, R is looking in what's called your working directory. Your working directory is the default directory R looks in for input files and also where R saves output files. So we have input files that we're using, we have scripts that we're using, those have directories, and we also have this thing called a working directory. And this is very difficult to like keep track of. One very simple and useful way to do this is to keep track of all these things is to use what are called RStudio projects. I promise I'm not like a shill for RStudio, but I think it's a great, nice piece of software. And these RStudio projects make project management really simple. So what you can do for RStudio projects is you can the way these work is you go to File, New Project, and it'll say New Directory, Existing Directory. I'm gonna create a new directory for my project. And it is an R project. And I'm gonna, you know, put it on my computer somewhere. It says you wanna create it as a subdirectory of a particular directory, that's fine. And I'm gonna call this, you know, using R efficiently session. Okay, so I'll create this project. And then RStudio does what it says. It says it switches to this project. Okay, what does that mean? The first thing that it does is it creates that directory that I told it to do. So in my file browser in this projects directory, it created this kind of using R efficiently session directory. Then it created this little file in there called an R project file. It has this extension RPROG, and it has this directory. So now in this directory, I'm going to save everything that I was working on. So I was working on this, wage analysis thing. I opened it up and I'm just going to save it in that directory. So that's my projects folder. I'm going to save it there. So you see it pop up there. And also, I'm going to find that data that I was using. I'm going to move it to that directory. So everything's in one directory. And if I go back to that directory, you'll see like all my files there. Okay, so why is this useful other than transparently having all your files in one place? When you close R, let me just go ahead and close R, and then I'll load it again. It'll be this kind of like fresh looking session with nothing in it. I can go up to this little project pane and go, hey, look, here's my recent set of projects using R efficiently. When I click on that, what R is going to do is it's going to change my working directory to this using R efficiently session directory that I created. And all my files are there, including my script. And in addition to that, now that R has set this directory, this new project directory as my working directory, I don't need this path anymore. R is going to know exactly what I'm talking about when I run this code without the path. So you can see I got no error. I'll just kind of confirm that by typing this read_DTA without the path. And there's my data. So these are project files. They're just files that tell RStudio, hey, set my working directory to this particular directory. And this is where I'm going to save my files. This is very useful for making your code and your data more portable. Like now I can just zip up this directory and send it to somebody, put it on Dropbox, SharePoint, email it, whatever. And if somebody opens up this R project file, all of this will pop up and they will be able to run my code and it will work for them, as long as they've installed the right packages and everything. But you won't have to worry about paths and, files in different directories. So hopefully that gives you like a taste of what you can do with our projects and RStudio projects and how that can be useful for project management.
Thanks.
Any last questions? Well, thank you very much for attending this session. On Thursday, we have a second STATA session. If you're interested, Zane Mokhyber, our data analyst extraordinaire, is teaching that session. I highly recommend you check it out if you're using STATA in your work. We will also send out reviews or a form for you to review this and all the other data bootcamp sessions to give us some feedback about what we could do, better next time. Please fill them out. I will include the code, like I mentioned, that we created. I'll upload that to the website so you'll have that. You can use that as a template. Sorry, it's not there already. And feel free to reach out to me or anybody on the EarnCon team if you have any additional questions. Thank you very much.